All right, in this video, we're going to look at finding the values of the composition of inverse trig functions. So when dealing with problems like these, it helps to sketch a right triangle, much like in the previous example, all those ones we did in the last video. So that's actually a big reason why every single one of those problems from example 1A through 1D, I drew a sketch of. You may need to use the Pythagorean theorem as well, depending on what information you're given and what information you're asked to find. Please keep in mind that we want to make sure we are within proper domains as well. So example 2, find the exact values of each if possible. So we have the cosine of the inverse cosine of 1/3. So we're going to start with the inside, this inverse cosine of 1/3. What this inverse cosine of 1/3 is going to do is going to sketch our picture much like we did in the last video. So if we would have started with inverse cosine of 1/3, we have 1 for x and 3 for r. So this inverse cosine of 1/3 is asking us what angle in standard position, if we took the cosine of that angle, would give us 1/3. Now, what this inner inverse trig function does is it draws this picture. From there, now we want to apply this trig function cosine to this angle in this picture. So as soon as we draw this sketch, we are done with the inverse cosine of 1/3 part. So now this problem boils down to, what is the cosine of the angle in this picture? So theta, again, is inverse cosine of 1/3, and now we're going to ask, what is the cosine of that angle? Well, cosine is x over r, which we have is 1 for x and 3 for r, so the cosine is 1/3. So cosine of inverse cosine of 1/3 is 1/3. Part B, the sine of the arcsine of -3/7. So here we have arcsine -3/7. The negative part means we're going to have the angle in the fourth quadrant, where sine is negative. So let's draw that picture. So the arcsine of -3/7 is going to look like this picture, where the y is -3 and the r is 7. Now, as soon as we do that, as soon as we draw that, we can ignore this arcsine -3/7 part. So now we want to know, what is the sine of the angle in this picture? So the sine of that angle is y over r, which is -3/7. So we had cosine of inverse cosine is 1/3 is 1/3. We have the sine of the arcsine of -3/7 is -3/7. Let's do the cosine of the arc cosine of 5/4. So might have an answer. Let's see if it works out. So arc cosine of 5/4, that's in the first quadrant because it's positive 5/4. We have x over r is 5 for x and 4 for r. So as soon as we do this, we draw this picture, and we get a domain error. Well, turns out that 5/4 is outside of the domain of inverse cosine. We can only take the inverse cosine of a value between -1 and +1. So when we get a domain error, we get no solution. Now, visually, the reason why that happens is in this first step, when we drew this picture, if we stop and look for a moment, we have the adjacent side is 5, the hypotenuse is 4. The hypotenuse has to be the longest side of any right triangle, and in this case, that's not happening. The hypotenuse is less than the adjacent side. So this picture could not exist in real life. There's no triangle we can draw where the hypotenuse is shorter than one of the legs. So in terms of sketches, yes, they work out, but for ones that can't exist in reality, such as this triangle, you will get a domain error, which means no solution for example 2C. Example 2D, we have cosine of arctangent of 5/12. So arctangent's positive, that's in the first quadrant. Y over x for tangent, so 5/12, and we put the theta in our picture, so that takes care of the arctan of 5/12. So we want to know, what is the cosine of this angle? Well, for cosine, we need the hypotenuse. So here we need to use Pythagorean theorem. So 12 squared and 5 squared is 169. Take the square root of that, and we get r is 13. So now we have all the sides of this triangle. The cosine of this angle is x, which is 12, over r, which is 13. So our cosine of arctangent of 5/12 is 12/13. 12 over 13. Part E, the sine of arctangent of 3/4. So once again, arctan 3/4. Y is 3, x is 4. We want the sine of the angle in this picture. For the sine of that angle, we need the hypotenuse, which means we need to use the Pythagorean theorem. And we're going to get r is 5. So now the sine is y over r, which is 3 over 5. So sine of arctangent of 3/4 is 3/5. Part F, the cotangent of the arcsine of -1/3. So arcsine -1/3 means our angle is going to be in the fourth quadrant. Good news is, and I'll explain this when we're done, if you don't put it in the fourth quadrant, it's okay if you put it in the first for your sketch. However, your answers might be negative, so just be aware of that. So I'll explain that more at the end of this problem. So we have the angle theta for arcsine -1/3. So we want the cotangent, which is y over x, which means we're going to need that x coordinate. So x squared plus, ignore the negative so you don't goof up, plus 1 squared equals 3 squared. So subtract 3 squared and 1 squared, we get 8. So the square root of 8, which is 2 times the square root of 2. And because it's along the positive x-axis, it's positive 2 square root of 2. If it was on the negative x-axis side, this would have been a negative 2 square root of 2. So another benefit to sketching is making sure your x's and y's are in the right spot. So cotangent is x over y, which 2 square root of 2 divided by -1 is -2 square root of 2. So the good news is, if you put cotangent of arcsine of -1/3 in your calculator, you're going to get a negative, 2 times the square root of 2 is about 2.828-ish. So you know your answer is going to have to be negative. So even if you put it in the first quadrant, just make sure that your answer comes out to be negative, because if you put this original problem in your calculator, it will give you a negative answer. All right, finally, part G, the secant of the arc cosine of 3/4. So we have positive 3/4 for inverse cosine. So it's in the first quadrant. X is 3, r is 4. We want the secant of this angle. Now, secant is r over x, so we don't even need to use Pythagorean theorem in this example. So the secant, r over x, is 4/3. So notice that if we do the secant of the inverse cosine of a fraction, or do the secant and inverse cosine, whatever this fraction is, it's going to give us the reciprocal, and this kind of explains why. Same thing with cosecant and arcsine and the others as well. So, all right, that about does it for this video. Thanks for watching. I'll see you.